Hello, now we will talk about linear interpolation. Sometimes the states encountered when solving problems do not fall exactly on the grid of values provided by the table. So in this case, interpolation between adjacent property should be performed in order to extract the property at the state given. So we do this using linear interpolation, and the tables are set up in a way that linear interpolation will result in a good accuracy. So I will show you an example of what linear interpolation is. So suppose we need to find the specific volume for water at a state where P is equal to 10 bars and T is equal to 215 degrees Celsius. So if we go to the pressure table to locate the state point, table A3, and we look at the pressure of 10 bar, we can see that the saturation temperature is 179.9 degrees Celsius. So from table A3, Tsat is equal to 179.9 degrees Celsius. So T in this case is higher than the saturation temperature at 10 bar. So we can say that the water in this case is a superheated vapor. So superheated vapor. So we can also draw this on a vapor dome. This is GV diagram to locate the state. So this is the pressure of 10 bar and the saturation temperature is 179.9 degrees Celsius, and we have a temperature higher than the saturation temperature, 215 degrees Celsius. So we can locate the state in the superheated region. So in order to calculate the specific volume V, we need to look in table A4, the superheated vapor table. So we go to A4, we look at the pressure of 10 bar, so this table, and we can see that we can't find the temperature of 215. The temperature of 215 is located between a temperature of 200 and 240. So we can, let's take the specific volume of the two temperature. So at a temperature of 200 we have a specific volume of 0.206. So at a temperature of 200 we have a specific volume of 0.206 meter cube per kilograms, and at a temperature 240 we have a specific volume of 0.2275. At a temperature of 240 degrees Celsius we have a specific volume of 0.2275 meter cube per kilogram. So what we need to know is at a temperature of 215 degrees Celsius we need to know the specific volume. So what we do in this case is a linear interpolation. So in order to show you how to do the linear interpolation, let's plot on a TV diagram the points that belong to T200 and the specific volume of 0.206. Okay, so I will put the specific volume in the y-axis and the temperature in the x-axis, because here the specific volume is unknown, so it's better to put it on the y-axis. So if we want to put the 2 points, the first point belongs to a temperature of 200 degrees Celsius and a specific volume of 0.206. So this is in meter cube per kilograms, and this is in degrees Celsius. And so this is the first point. The second point has a temperature of 240 degree and a specific volume of 0.2275. So now we will assume that the variation between point 1 and point 2 is linear, so we draw a line here, and the problem is now to calculate at a temperature of 215 degree, which is here, to calculate the specific volume. So if we draw the 2 triangles, this is the first triangle and this is the second triangle. Okay, and let's label this triangle. The big one is A, B, C, and the smaller one is A, D, E. So here the slope between lines AB and AC can be calculated using the 2 triangles, the first ABC triangle and the second ADE. So the first triangle, we can say that it is BC over delta Y over delta X, so BC over AC. Or from the smaller triangle, we can say that it is DE over AE. So in terms of the coordinates of the point, so it is BC, it is 0.2275 minus 0.206 over AC, which is equal to 240 minus 200, should be equal to DE, which is V minus 0.206 over AE, which is equal to 215 minus 200. And we can now calculate the specific volume from these 2 relations, and it will be equal to 0.2141 meter cube per kilograms. From my personal point of view, I prefer to write this equation as in this manner. So what I do, I say that at a temperature of 200, I have a specific volume of 0.206, and at a temperature of 240, so I have a specific volume of 0.2275 cube per kilogram. So at a temperature of 215, okay, what is the specific volume? What I do, I prefer to do the following. So I do this this way of calculation. So the second row, so I have 1, 2, 3, 3 rows. So always the second minus the first over the third row minus the first should be also equal to the second row minus the first over the third minus the first. So it's similar to this equation, since this numerator we can put it under v minus 0.206, and this denominator also you can replace it here. So it will be delta t over delta t is equal to delta v over delta v. So it is the same here. So we have 240 minus 200, sorry, 215. So the second minus the first over the third row, 240 minus the first should be equal to the second minus the first over the third minus the first. And similarly you will obtain the same result.